All right, in the last unit we talked about circles, but we were talking about how to find the length of a radius, or how to find the length of a diameter, or a circumference, or an arc, or a chord. Now what we're going to do is talk about the area of a circle, and more specifically about how to find the area of just like part of a circle. So before we do that, I want to review really quick what the parts of a circle are, or at least a few of the parts of a circle, so that when we start using them to find area, we know what we're talking about. So if I start at the center of a circle and I draw a straight line out to the edge of the circle, that's called a radius. If I instead start at the edge of the circle and draw a straight line that passes through the center, it's called a diameter. Okay. If I know what the diameter of a circle is, I can solve for the radius by just cutting it in half. Or if I know the radius, I can find the diameter by multiplying it by 2. In other words, if I knew here that the diameter was 10, then the radius would have to be half of that, which is 5. Or instead, let's say I knew that the radius was 15. If I knew the radius was 15, I could just double that to figure out the diameter. So if the radius is 15 and I double that, that would mean that the diameter is 30. So in other words, the radius is half the diameter, or you could say the diameter is twice as big as the radius. All right, so what's the area of a circle? What's the formula for figuring out the area of a circle? It's right here. It's just pi times r squared, and r being radius. So if I know the radius of a circle, I can figure out its area. So if I go back up here and I know the area, or I know the radius of this circle is 15, and I want to apply this formula to figure out the area, I would just say area is equal to pi times 15 squared. 15 squared is 225. So the area of this circle, I could either say it's 225 pi, or I could actually go through and multiply that out. So if I had 225 times pi, the area of the circle then would be 706.86 units, square units, whatever I was using. All right, so moving on, that's pretty easy. Let's back up a second. If I knew the diameter of a circle and I wanted to know the radius, what would I do? Well, the first thing I would have to do is cut that diameter in half. That would give me the radius. Then I could plug it into this formula. All right. Now let's figure out what the area of just half of a circle is. First thing I need to know is how many degrees there are total in a circle. Don't say 180 because it's 360. So 180, if you said 180 in your head, you were thinking of triangles. All right, well, I know that the total number of degrees around or within any circle is 360. What about half of a circle? Well, now it's okay to think 180 because 180 is the correct answer. 180 is half of 360. So if there's 360 degrees in a whole circle, there's only going to be 180 in half of the circle. So if I only want to know what the area is for 180 degrees of a particular circle, here's how I do it. The formula is going to look pretty similar to what it was up here. So I'm going to say area is equal to pi r squared, but I got to put something in front of that. I'm going to put a fraction right here because I only want to know a fraction of that circle. And the fraction that I want to know, in this case, is 180 over 360. All right, so I want to know 180 over 360. Well, the easiest thing to do with that fraction is convert it into a decimal. So what is 180? What is 180 divided by 360? Well, 0.5. So to figure out the area of half of a circle, it's going to be the area equals 0.5 times pi r squared, right? So in other words, let's do an example down here. If I have a diameter right here, I know that basically this angle is 180 degrees. So if I want to know the area just contained within this half of the circle, I'm going to use this formula right here. Just area equals half, or 0.5 times pi r squared. So let's say the radius in this circle, let's say the radius is 5, just for an easy number. What I would do is I would say the area is equal to 0.5 times pi times 5 squared. So area equals 0.5 times pi times 25. So the area would be, if I multiply 0.5 times 25, I would get 12.5 pi. Or I could multiply that out and I could say, well, what's 12.5 times pi? 39.27 square units, whatever I was using, feet, inches, yards. In other words, the amount of space taken up by just half of this circle would be just under 40 square units. Let's say instead I wanted to know how much area was taken up by just a quarter of this circle. Right? So I'm going to erase what I have here. And instead, what I want to know is how much area is there inside of 1/4 of this circle. So if I draw a line right here and one right here, so that I have a 90-degree angle right there. What is the area inside of just this piece right here? Well, I'm going to come back up to this formula, but I'm going to change things around a little bit. So if you already have this written down, you can leave it, or you can find space to draw this, to write down this next example I'm going to do. Otherwise, just watch what I do. So now, instead of wanting to know half of the circle, or 0.5 of the circle, I want to know how much area is there in 90 degrees of this particular circle. So I'm going to go back up here and go back and do what I did right here, but now I want to know what 90 of the 360 times pi r squared would be. So all I did was I changed this 180 into a 90, because instead of wanting to know 180, or like half of the circle, I want to know what 90 out of 360 degrees is. In other words, 1/4 of the circle. So I'm going to convert that 90 over 360 into a decimal. So I'm going to say, what's 90 divided by 360? 0.25 times pi. And if, let's say, the radius is still 5 squared. Okay, so I'd have A equals 0.25 pi times 25. 25 times 0.25. So I could say the area is 6.25 pi, or I could multiply that out. 19.63. Okay, so really all I'm doing here, if this is confusing, it's okay. It won't be for long. I think you'll get it once you do a couple examples. But basically, this is kind of the key component, right? The rest of this formula just comes from up here, where we were trying to figure out the area of the whole circle. All we're doing, we're taking that formula, the pi r squared, and we're putting a fraction in front of it where 360 goes in the bottom, because that's how many degrees there are inside of an entire circle. And 90 or 180 or whatever number we want goes on top, depending on what size the sector of this circle is that we want to figure out the area of. I think this will make more sense when I do some examples here. What I'm going to write up at the top is sort of just the general formula that I'm going to use to figure out the area of a sector of a circle. That's what these blue pieces are. They're sectors of a circle, or parts of a circle. So it's going to be area equals pi r squared, but we're going to put this fraction in front of it. And 360 is always going to go in the bottom, because that's the total number of degrees inside of a circle. On top of that 360, we're going to put an x, and x is just going to be the number of degrees, oops, not digress, degrees in the sector we want the area of. So, number on 3a, the area is equal to something over 360 to start with. Well, the sector that we want to know the area of covers 53 degrees. Pi, the radius it says here is 4, and I'm going to square the radius. So I'm going to figure out what is 53 divided by 360. That's going to be the decimal that goes out in front. And it's 0.147 times pi, and then 4 squared is 16. So now I have 0.147 times pi times 16. If I do this times this, so in other words, if I take this decimal that I have right here and multiply it by 16, I'm going to get 2.35. What was that? 2.3555, so I'll call it 2.356 pi. And then if I multiply that, I get 7.4. So the area of this sector right here is about 7.4 square feet. 3b. We'll do this one a little bit slower. The area equals some fraction with 360 in the bottom times pi times r squared. What is the measure of this arc that sort of creates this sector that we want to know the area of? Well, it's obviously 148. So that's what goes right there. What is the radius of this circle? It's 6. Okay, so now we just have numbers to deal with. First thing I want to know, what is this fraction as a decimal? So I'm going to say, what is 148 divided by 360? Oops. .4111. So let's call it 0.41 times pi times 6 squared, which is 36. Okay. Now all I really have to do, I've been doing it a different way till now, but I'll do it kind of an easier way now. I'm just going to multiply these three things together. So I'm going to start all over. I'm going to say, what's 0.41 times pi times 36? And that's going to give me an area for this blue sector of 46.37. And here we have square meters. Last one. Now our sector covers most of the circle. And what it's doing here, it's trying to kind of trick you. It's not giving me the angle for the sector that I want. It's giving me the angle for the other sector, like the part that I don't want. So what I got to do first on this one is figure out what this angle would be. Okay, so my x here is going to be 360. That's the total number of degrees in this whole circle, minus the 65 in this sector that I don't want. All right, well, 360 minus 65 would leave me with 295. Okay, so now I know x, and now I can create an equation to solve this. So the area is going to be my 295 over 360 times pi times r squared, and the radius here it says is 11 inches. So let's figure out what 295 over 360 is as a decimal. Let's call that 0.82 times pi times 11 squared, which is 121. So let's get on the calculator, and I'm just going to do those right in order. So I'm going to say 0.82 times pi times 121. And it gives me, this is my answer, 311.71. And here we have inches, so square inches. Since you guys love word problems so much, I'm going to do a couple of word, or at least one word problem here with circles. It says Chelsea's baking pies for a fundraiser at her school. She divides each 9-inch pie into 6 equal slices. So what I'm going to do first, I'm going to cut this pie into parts, into 6 equal parts. It doesn't have to be perfect, so what I'm going to do is I'm going to say, okay, well, I'm going to cut it long ways. Actually, probably easier if I use a different color. That's not any better. And then I'm going to cut each of those into 3s. So there we go. We have a pie. I don't like it. We have a pie cut into 6 roughly equal pieces. And I want us to know what's the area in square inches for each slice of pie. Well, what it tells me right here by saying 9 inches, when you see something like that, what it's saying is that the whole entire pie, it actually has a diameter of 9 inches. So if I want to know the radius, or in other words, like one side of each slice of pie, it's going to be half of this, so 4.5. So R would be half of 9, which is 4.5. Next thing I need to know is, like, what's the angle for each one of these slices of pie? Well, if they're all the same, it would just be 360 divided by 6, right? There's 360 degrees total in that pie. Each one of these 6 pieces is going to be 1/6 of that, so 360 divided by 6 is 60 degrees. So X for this circle here, or for each piece of pie, is going to be 60 degrees. So now what I'm going to do is I'm just going to use the formula we've been using. So the area of each piece of pie is going to be 60 over 360 times pi r squared. So times pi times the radius squared. The radius here I already said was 4.5, and I'm going to square that. All right, so what is 60 divided by 360 as a decimal? 1.67 times pi, and then 4.5 squared. Oops. 20.25. So now I just need to multiply those 3 things together. That'll tell me the area of one slice of Chelsea's pie. That times pi times 0.167 is 10.62. So one slice of the pie is about 10.62 square inches. There's one part of the question. Then it says if each slice costs 25 cents to make and she sells 8 pies at $1.25 for each slice, how much money will she raise? In other words, what's her profit? Okay, so each slice costs 25 cents to make. So $0.25, same thing as 25 cents, times 6 pieces in every pie. So 0.25 times 6 pieces in every pie, and she's going to sell a total of 8 pies. This is how much it's going to cost her to make those 8 pies. Right? It costs her $0.25 for every slice of pie, and she's making 8 pies. So I'm going to do 0.25 times 6 times 8. So it costs her $12 to make her 8 pies. So that's her cost. If I want to know what her profit is, I need to figure out how much she actually made. Right? The difference between what she made on the pies and how much it cost her to make the pies, that's going to be what her profit is. So she sold 8 pies for $1.25 each. So she sold 8 pies. She made $1.25 on each of them, or for each of them. So what is 8 times $1.25? Oh, I screwed up. She actually made $1.25 per slice of pie. So she sold 8 pies. Each of those 8 pies had 6 slices in it. And then each one of those slices was $1.25. I actually need to do 8 times 6, right? 8 pies, 6 slices in each pie, $1.25 for each slice of pie that she sold. So it's going to be 8 times 6 times 1.25. So 8 times 6 times 1.25 is $60. So she spent $12 to make the pies. She was paid $60 when she sold the pies. So her profit is going to be the $60 that she made minus the $12 that she had to spend to make the pies. 60 minus 12 is 48. So Chelsea made $48. All right, let's figure out some other stuff. So we've figured out areas. Now what it wants is for us to figure out something else given the area. So it says for this circle, or for this sector right here, where the area is 66 square centimeters, it wants to know this distance right here, which happens to be a diameter. Okay, well, diameter is not part of the formula, but radius is. So if I can solve for radius, I can then figure out what the diameter of this circle would be. All right, so let me show you what I mean. So I know that the area equals x over 360 times pi r squared. All right, let's fill in what I actually know. I know the area is 66. And I know the part of the circle I'm looking at is 180. And I know pi r squared is what goes right there, but I don't know what r squared is. I'm going to separate these two. All right, 66 equals, I know 180 divided by 360 is 0.5. Pi is just pi, and then I have r squared. So what I want to do is I want to get this r squared by itself. So I'm going to divide both sides by 0.5 pi, because by doing that over here, it's going to get rid of both of those things. So over here, I'm also going to divide by 0.5 pi. So r squared is going to be equal to 66 divided by 0.5 pi. What is 0.5 pi? Well, it's pretty simple to figure out. 0.5 times pi is 1.57. So 66 divided by 1.57 is 42. I think it said 0.03. So I know r squared. I want to know what r is, so I'm going to take the square root of both of those. R is going to be 6.48. So that tells me the radius, right? So that would be like this part right here. But I want to know the whole thing, so if this part is 6.48, this part down here would be 6.48. If I add those two together, it'll tell me x. So x is just going to be 6.48 times 2. 12.97. So x is 12.97. And I think that was centimeters. All right, what about 28? Now it wants to know this angle in here, okay? Area of this piece of the pie, or this piece of the circle, 94, equals x over 360, right? Because this angle in here is what I don't know, times pi times 14 squared, right? Because 14 is the radius. So I got to get this by itself somehow. 94 equals x over 360 times pi times 14 squared. But let's figure out what 14 squared is. 196. Okay, so I want to get this by itself. So I'm going to divide on both sides by 196 pi. Right? That's going to get rid of those two things, leave me with just this x over 360. So I need to figure out what 196 pi actually is. And it is 615.75. So x over 360 is equal to 94 divided by 615.75. Okay, so all I did here is I flip-flopped around what I had. All right, so easiest way to do this, well, we'll do it the long way. It'll be easier to show you. So x over 360, still what I have on the left. On the right-hand side, I have 94 divided by 615.75. So 94 divided by 615.75 is 0.15. Yeah, we'll just leave it as that. Now I want to know x, so I'm going to multiply by 360 on both sides to get x by itself. X here would be this times 360. 54 point, we'll call it 54.96. And because we're talking about an angle here, it's degrees. All right, last one. What is my x here? Well, x on this one is the radius. Okay, so I'm going to solve for the radius here. The area, I don't need to write the a, the area is 128. And that's equal to 152 degrees over 360 degrees times pi times r squared. So let's figure out what 152 divided by 360 is. 0.422. Let's leave this. Okay, I'm going to divide on both sides by 0.422 pi. To do that, I need to know what number I can use for 0.422 pi. So I'm going to take this and multiply it by pi. I get 1.33. So r squared, right, because these two are going to go away. So r squared is equal to 128 divided by 1.33. And that's 96.24. Now I'm going to take the square root of both sides so that I can figure out what just r is. I need the square root of this. 9.81. So the radius of this circle would have to be about 9.81 feet.